not seeing 50 psi air source, and it would kick on the compressor. I actually worked at a hospital where they remodeled the ER and they failed to put compressed air in. It's like, what were you thinking?
A little important.
Little important. Well, it basically meant that all my ventilators had to have compressors, which is an extra $2,000. So it's like, just drove the cost of business up. All right, the ventilator is got a couple different parts. This middle part here is called the breath delivery unit. It's basically the guts of the ventilator. Got a battery here that'll power the ventilator for about 45 minutes. So it's, if nothing else, it's good for transports. And this top part is called the graphical user interface, the GUI, or more commonly known as the screen. The two of them are connected together by a cable. And what can actually happen is if the GUI fails for whatever reason, the ventilator can actually keep on ventilating. You just don't have any graphical ability for it. And by the way, this is the Pure Bennett 840. This is the ventilator that I sold for 6 years. I'm very familiar with it. Power switches in the front, which you're going to find is very unique because most of them are hidden somewhere on the back. Go figure, right? Before you do that, we turn it off. A couple things you need to have. This is the two patient part. Maybe it says two patient. So that's coming out of the ventilator. We want to have a filter there, and then there's a filter that goes on the front part and coming back into the ventilator. PB is really the only manufacturer who advocates for a filtering of exhaled gas. And in most cases, it probably doesn't make a difference, but in the case of, say, I'm ventilating a patient who has tuberculosis, kind of would be nice to filter that prior to dumping the gas into the atmosphere. And then the circuit we have is the universal circuit. It can go on any of the ventilators. And there is, if you'll notice here, a couple of ports. This is one that is actually for a temperature probe. So this would be the inspiratory side. And this would be the expiratory side. Now it really doesn't matter in truest, if I'm not using a heated humidification system. One thing you want to do is when you turn this unit on, you want to make sure it is not connected to anything. Okay? If you have it hooked up, say, to a test lung or even your finger over it, it's going to sense the fact that a patient is there. But you haven't told it what kind of patient is it. Is it an adult? Is it an infant? Is it a neonate? Because it can ventilate all three. So it'll go into what's called safety ventilation. And I know we'll probably see somebody do it today because we always do. And if that happens, turn it off, remove it, and start all over. Thanks, Brandon. All right, so the screen is set up so that you have the top part telling us what's going on with the patient, the bottom one being the settings. This also tells us what the last SST, short self-test, is, and that's what we're going to start off with. When you process the ventilator, throw away the old disposable stuff or process the reusable stuff, you want to go ahead and do an SST. That basically verifies the ventilator is functioning properly and is able to be used clinically on patients. We're going to touch the SST button, and right here is a little test button that you need to push. It's timed, so you got 5 seconds from the time you press the SST until you get that. It'll then call up a screen that says what kind of patient do you have, adult, pediatric, neonatal, because the circuits are going to be different sizes, and what kind of humidification you're going to have. We're going to go with an HME. However, our other options are to have a heated water bath with non-heated expiratory tube or a heated expiratory tube. In other words, if you remember back to one of the high flow systems where we were using that.
The Arizona Optic.
Yeah, the heated humidifier. Now this volume that it's asking for here is how much volume is in here. Well, how the hell would I know that? The model number tells you. So this is MR290, so it's 290 milliliters. Well, we're going to go ahead and just use an HME for simplicity's sense. Okay, so we follow the directions here, use knob 2 to adjust to where you want, and then press the accept key. Connect circuit with inspiratory filter and without humidifier, which is what I have. Block the Y. Now you can put your thumb over there, but I find it easier to just use a cork. Hit accept. And what it's going to do is it's going to go through a series of tests internally. What it's doing right now is it's putting a known flow of O2 and a known flow of air at 3 different flow rates. It's coming out here and measuring that there, and it's seeing if it's correct. So I'm putting out 5 liters. It wants to see 5 liters coming back.
Closed system,
An intelligence system.
an intelligent system.
By the way, this can be for vertically challenged people, and it can also be turned. And you would do this again whenever you process the ventilator, but also if you either change the circuit or if you add a humidifier. So let's say I start off on an HME and 2 days down the road I want to use a heated water bath, I got to go through the SST again. Connect humidifier if applicable.
Where would you hook up the humidifier on this?
This one doesn't have a thing, but there's usually a, if you take a look at the other ones, so there's usually a bracket
Mount?
that would fit there. Disconnect at from patient port.
And this one has one,
There, you can see it over there.
right here. You just plug it in here.
Oh, gotcha.
So disconnect at from patient port. That's the from patient port. Okay? Sister Mary Margaret will be very upset because I'm having 2 prepositions in a row. Connect to from patient port. What it's measuring is the resistance of this filter. And if the filter's resistance gets elevated, it'll tell you that you need to replace the filter. Taking off. Unblock Y. And what it's measuring here is the inspiratory resistance, and then it's going to also have the expiratory resistance, so it knows what the resistance in these tubings are. Block Y. And now what it's going to measure is the compliance of the circuitry. If you watch, the circuit will actually expand.
There you go.
Okay? So when you're ventilating a patient, part of the gas the ventilator is delivering is lost in the circuitry. We call that compressible volume. Okay? When the ventilator actually functions, it's going to go ahead and let's say I wanted a tidal volume of 700. It knows how much volume is being lost in the circuitry, 2.64 milliliters per centimeter of water. It knows how much pressure was being used to deliver that breath on the prior breath. It then factors that in. So let's say it was taking 10 centimeters of water, it would go ahead and say, well, 26.4 milliliters is being lost in the circuitry. I'm going to put out 726.4, knowing that only 700 is actually delivered to the patient. There may be a problem like that you may see on a future exam. Just saying. Unblock the Y, and then we can exit the SST. It's going to go ahead and shut itself down and power itself back up again. Okay, we're going to go ahead and do a new patient. Our patient is 75 kilos, and if you look at the PE, you'll end up seeing this. We're going to do invasive ventilation. We're going to have the mode as assist control, volume control, and we're going to, I believe, have flow trigger first, or we have pressure? Whatever.
Yeah.
Your options there
Gonna
is
be
either
switching
pressure
it
or
in.
flow. It's based upon that 75 kilos. It's going to come up with some settings that are based on that ideal body weight. You can just use the ventilator at that point. It's safe to use. The settings are safe. Or you can go ahead and plug in your own settings. For the purposes of the PE, we're going to go ahead and just plug in the settings. We're going to have a rate of 15. And a tidal volume of 700. Peak flow of 60. Now, if you'll notice what that does is it sets a specific I time and E time and an IE ratio. Okay. Flow triggering of 3. I believe that's what it is. We're going to put the FiO2 to 21% just so we don't burn through gas. Okay. PEEP of 5.
I tell them so it's not to increase their lab fees.
There we go.
That
That drives
has
home.
Yeah.
Once you like those settings, you can go ahead and hit accept. Those things, and by the way, this portion here is called the sandbox, because that's where we're going to play. Okay. Now these are my settings, and what it's doing is it's waiting for a patient. And it'll sit like that forever until it sees a patient being attached. Some hospitals that do open hearts, they'll set up the vent in the patient's room while they're still in OR, knowing what the patient's size is. They can go ahead and now plug in all their values and let it sit there. When the patient rolls back through the door, excuse me, we go ahead and hook them up. It recognizes now that a patient has been attached, and it starts ventilating. Okay? Now, if you notice, the alarms that went off are prioritized. And then finally going to, get your butt in here. Or, here's George Stetson.
Oh,
One of the first buttons that you'll identify on any ventilator is the alarm silence. 'Cause that's the important one. All right. So what we now have are our patient data. That is up there. And how am I still getting a peak pressure? Oh.
his compliance is pretty low.
Who screwed around with that?
Who the heck knows? Looked like something fun to do, didn't it?
So when you first turn on, it's going to pop up to the screen where it shows you what the apnea settings are. You not only need to put in ventilator settings, you need to put in apnea settings, you need to put in alarm settings. Okay? And then you'll call us over. Apnea settings are going to be exactly the same as what you have set above. So I need to change this to 15, this to 700. This is 60. You can leave the O2 as 100% because in reality, we're never going to have an apneic episode, right?
Uh-huh.
In assist control, you got a backup rate. So there's never going to be apnea. However, you always set apnea parameters because some doc may come in, throw them into spontaneous just to see how they do, and not tell you. And I want apnea to be there in case that patient is breathing spontaneously, it goes apneic. Make sense? Lie to me. Hit accept to accept those in, and now I can go ahead and set my alarm parameters. Going across, first one is a high pressure alarm. We want the pressure alarms to be 10 to 15 centimeters of water above what the patient is doing. So right now they're doing 21. You can go ahead and set it anywhere 10 to 15 above that. Me, I'm weird. I know you know this, you find this odd.
Put it at 12 and a half.
No. Yeah. Put a prime number like 31, just to piss people off.
Yeah, we would do that.
We can do these as batch settings, meaning I can go all the way across and do all of them. The next one, and this is the one that people forget to set because it's not visible, is the respiratory rate. Again, 10 to 15. So we're at 15, let's go ahead and put it at 27. Volume alarms, anything that has to do with a volume, minute volume, tidal volume, are always going to be 10 to 20%. So what we typically use is 0.85 times whatever the value is, and 1.15 times whatever the value is.
Anybody get a calculator?
I got it. So what I'm doing is 10.5 times 0.85 would be 8.92. So my low is going to be 8.92. Better do the top one first. 10.5 times 1.15, 12.07.
Oh.
10.5 times
That's where the
1.5.
silence alarm button is.
And my tidal volume is
That's by the 0.85.
700 times 0.85. 595. Let's call it 600. And 700 times 1.15. 800. Okay. Now the last column is tidal volume, low and high tidal volume for spontaneous breaths. We don't have any spontaneous breaths, so it's academic. And now we're ventilating. I got my alarm set, I got my apnea set, I got my setting set. Okay. Let me go through these buttons down here in the bottom. This first one is a screen lock. All you gotta do is press the screen lock to unlock it. I was talking to the engineers and I said, you know, have this set up so if it doesn't recognize the person's fingerprint, it sends an electrical current back through. Somebody's screwing with my ventilator. They didn't like the idea. This is a volume alarm that'll make the alarm louder or softer. Okay. It also doubles as a horn in case you're transporting. Alarm silence we talked about is a 2-minute silence. We can hit reset to reset that value. There's a little info screen that pops up, kind of a mini operator's manual. So if you forget how to do something,
It does.
it's right there for you.
Like use
Knock yourself out. 100% O2 button will do 2 minutes of 100% oxygen. It'll also calibrate the galvanic fuel cell oxygen analyzer on the inside. So if we know we're going to suction a patient, you can push that, go ahead and pre-oxygenate them, and after you're done suctioning, you can post-oxygenate. Manual inspiration will go ahead and give us a breath when we touch the button. And then there's these two last buttons, expiratory pause and inspiratory pause, that we're going to use to measure compliance, resistance, and auto PEEP. Okay? Let me take this slowly. Okay? The measurement of area resistance has to be done when the flow rate being used is a constant flow. Right now, my flow is not constant. I'm in a decelerating ramp, meaning that I start off with a very high flow, and by the end of the breath, it's coming down to 0. Right? So to do a measurement of compliance and resistance, go back to vent setup, hit continue, note my I time, 1.28 seconds, change it to a square wave flow pattern. Now what I need to do is adjust my peak flow until I have the same inspiratory time. 1.28. Okay? Now when I hit the accept button, instead of being a decelerating ramp, it's going to be a square wave flow pattern. So watch what I end up doing, because this is going to be in sequence. Hit accept, hit inspiratory pause, hit vent setup, previous setup, accept. I'll go through that again.
I'll watch this at night. Yeah.
But notice what ended up happening. I had a square wave. I have a plateau, 14. My compliance, my resistance. Compliance is expressed in milliliters per centimeter of water. We've, to this point, been typically expressing it as liters per centimeter of water, right? What's the normal lung compliance? 100 mLs per centimeter of water, or 0.1 liters. So if it's 100, this compliance is 85. It's pretty close to normal. And that's actually an acceptable compliance for a patient who's intubated and mechanically ventilated. So let me go through those steps again. Use the sandbox, vent setup, continue. Note my eye time. Make it a square wave. Make it a decreased flow rate so I get the same eye time. Accept. Inspiratory pause. Vent setup. Previous setup. Accept. So they had one breath that was that funky setup, and then we're back to normal. Okay.
So you change your settings to get the inspiratory pause, then hit the undo button to go back to normal.
Exactly.
Cause it's not comfortable to breathe in a square way.
And a pause.
And a pause, yeah.
The expiratory pause button will give us the auto peep reading. Okay? Auto peep is again trapped gas that's not being allowed to fully exhale. So if you take a breath in and exhale halfway, and you try to breathe like that, that's very uncomfortable, right? So all I need to do is just touch the button. It will go into the maneuver. It'll lock the valves, measure create a zero flow state, and this is the total peak that is read. This is the intrinsic peak, or the auto peak. So it's 0.1 negligible amount of auto peak. Okay. And by the way, if you ever forget or want to know what the initials mean, just touch the thing. It'll tell you what they're like. F. What does F stand for?
Frequency.
It's the freaking frequency.
It's not flow.
It's not flow. That's right. Okay. So what you'll do is you'll put in your settings, alarm settings, apnea settings, call us over. We'll go ahead and take a look at those. We'll have you measure compliance resistance, plateau pressure, and auto peep. Then you're going to put them into spontaneous. Okay? So far so good?
Why did we need to do a square?
Because you can't measure area resistance without being in a square wave flow pattern.
So that we have to do with
Watch what happens when I measure an inspiratory pause without putting them into a square wave. You get dashes.
Oh, so
It
we're
says,
trying to get...
I don't got a constant flow. I can't measure area resistance.
Gotcha.
Gotcha? Cool beans. All right. So now we're going to have you put the patient into spontaneous breath. And again, we go to our vent setup. Instead of assist control, I want the mode to be spontaneous. Notice there's now a spontaneous breath type. We're going to make that spontaneous breath type tube compensation. And we're going to also put them into pressure triggering. Why? Because it's just fun. Hit continue. It's going to ask us a couple of questions. How much percent support you want? You always want 100%. It doesn't make any sense not to have 100%. In other words, if you need to have 3 centimeters of water, why the hell would I not give you 3 centimeters of water? 2 things we're going to tell you. We're going to tell you the inner diameter of the tube that you are using. Let's say it's 8.5. And we're going to tell you whether it's an ET2 bird trait. Now, if you remember back, I know you don't because you blotted it out of your memory, Poussin's law. Poussin's law talks about the pressure drop across a tube being affected by the flow rate and the length, and inversely related to the inner diameter. I'm telling it 2 of those 3 parameters. It knows what the instantaneous flow rate is as it's delivering the breath. And what it does then is it applies just enough pressure support to overcome the resistance of the tube. That's what tube compensation does.
The same way you compensated for...
Well, it's
That's
a little bit different because this is compensating for volume loss within the circuitry. This is actually measuring flow rate and adjusting the pressure support level to just match the patient's resistance of their airway. And it does this in the time it takes you to blink. It's updated 6 times. So that's how fast it's reacting. One of the things we're going to want to do here, though, is have our spontaneously breathing setup. So these. Okay, ahead and put them into my spontaneous mode now. Because they're now in a spontaneous mode, I gotta reset my alarms. Because they're gonna be different. So you're gonna go through and set your alarms. One of the things you'll notice is there is I got a spontaneous tidal volume that I wanna end up setting.
And it's the same thing.
Same thing, times
Roll
0.85.
back.
Ooh, well, that wasn't right. 337 times 0.85. 290. And 332. And 1.5 is 3. Now, one of the quirks of this ventilator is that the two high tidal line alarms are tied together. I don't know why they designed it that way, they just did. So we need to come down on the mandatory high tidal volume to be able to accommodate that. And then we need to set, again, I would just go ahead and set that one, 5, 50. Close enough for government. One other alarm that we have here is this one on the very end, and we're gonna set that the same as this one. It's at 3.0. 380. This is what is called a runaway alarm. We're assuming with tube compensation that all of the resistance in the circuitry is a secondary to that tube. Doesn't take into account things like secretions or bronchospasm or anything else. What we don't want to happen is it for, let's say we had a lot of secretions, it's going to interpret that as having a higher resistance and going to boost the tidal volume and boost the tidal volume, boost the tidal volume. We don't want it to go crazy. So we have a runaway alarm that is there. Okay? Call us over, we'll check all your alarm settings, move on to the next part, which is we want to put them in pressure support instead of tube compensation.
Pay attention to the tidal volumes.
In pressure support, or back up, in tube compensation, the ventilator is determining how much pressure support to apply to overcome the resistance. In pressure support, we're doing that. So we're going to go ahead and set this up so we're on 15 of pressure support above our baseline of 5 of PEEP. And if you notice, it even says pressure support of 15 above PEEP. So it's always referenced to the PEEP level. Similar to the delta that we did with BiPAP. Okay? Hit accept, and we'll get into what this one is and what that one is in the fall. The rise time and the e-sense. So now what we end up having, I got some alarms going off. Again, I gotta reset my alarms.
Oh, that's a lot of tidal volume.
Right.
Then,
Okay? And that's it. Then you'll call us over and we'll look at that setup. Aren't you excited?
oh my God. One time around.
Well, wait, this is only one. We got 4 more.
Okay, give me like 3 minutes.
And again, watch what